Objective 1.8, Quadratic Inequalities. We've spent a lot of time with quadratic equations in this chapter, but now we want to take a look at what happens with quadratic inequalities. So our goal is to be able to graph quadratic inequalities in two variables and to solve quadratic inequalities in one variable. So a little bit of vocabulary to get us started, mostly just looking at the forms that quadratic inequalities can take. And notice that we're looking at the difference between two variables and one variable. Okay, so in these cases, you'll notice that our ax squared plus bx plus c is always being compared to our second variable of y. Whereas in these cases, our ax squared plus bx plus c is simply being compared to 0. Okay. Alright, so in the first example, we want to be able to graph a quadratic inequality. So let's say we want to graph y is greater than negative x squared plus 4. Our first step is to graph the equation y equals negative x squared plus 4. This will establish the boundary between the solutions and the non-solutions. So in this case, our boundary is going to be a parabola instead of a straight line. And to get that parabola, we simply follow the same steps that we used in objectives, that should be 2.1 and 2.2. So at the beginning of the chapter, when we talked about graphing parabolas, we should already know how to do this, and we're going to use those same steps. Make sure you pay attention to whether the curve should be solid or dotted. So once you decide where the parabola should go and you've got all your points in place, when you go to draw the parabola, make sure you're drawing it correctly, drawing it solid or dotted based on the inequality. Which one should we draw in this case? Well, hopefully you notice that we should draw a dotted line because we are dealing with an inequality that is strictly greater than. So that's going to be a dotted curve when we're ready to draw it. All right, so let's go through the process here. Okay, so we have y equals negative x squared plus 4. First thing we need to do is find the vertex, which is at 0, 4. And so we can plot that point, which will be right there. We should also already have a sense of what this parabola is going to look like because we're dealing with an a value that is a negative 1. So we should already know that this is a parabola that's going to open down. And when we start to find other points, that should confirm it. So a couple of other points that work are the points 1, 3 and 2, 0. So I can plot those points. And then I can use the axis of symmetry, which in this case is the y-axis, to simply reflect those 2 points to the other side. And now I have a really good idea of what my parabola should look like. And when I go to draw it, remember we need to draw it as a dotted line. All right, now step 2 is to determine where to shade the graph, because we're not just looking for the values of y that are equal to negative x squared plus 4. We're looking for all of the values of y that are greater than negative x squared plus 4. So again, probably the easiest way to do this is to pick a test point that is not on the boundary, so not on the parabola. And 0, 0 is still the easiest point to test if possible, if it's not on our boundary line. Then I shade according to the results of the test point. If it's true, then that's the section I'll shade. If it's false, then I'll shade the other section. So in this case, if I test 0, 0, which is not on the parabola, I end up with the fact that 0 is greater than 4. Now, since this is a false statement, that means that the inside of the parabola is not where my solutions are, because that point 0, 0 gave me a false statement. So my shading then should go on the other side of my parabolic line. So this is the part that gets shaded up above. All right, why don't you give one a try? Graph y is greater than or equal to x squared plus 2. You should have a grid there on your notes paper, so just pause your video for a second, go through the process we just talked about to graph your inequality, and come back when you're ready to check. All right, so this is what your graph should look like. Your parabola has a vertex at 0, 2. You've got your other 4 points to make the 5 points needed for your parabola. This time we draw the parabola with a solid curve because we are greater than or equal to. And when we test 0, 0, we find that that's false, so it's this part inside of the parabola that gets shaded this time. All right, so that's how we can graph quadratic inequalities. Now, let's take a look at what happens when we want to solve a quadratic inequality. And for that, we're going to get a little bit of help from Salman Khan and Khan Academy.
Welcome to the presentation on quadratic inequalities. Before we get to quadratic inequalities, let's just start graphing some functions and interpret them, and then we'll slowly move to the inequalities. Let's say I had f of x is equal to x squared plus x minus 6. Well, if we wanted to figure out where this function intersects the x-axis, or the roots of it, we learned in our factoring quadratics that we could just set f of x is equal to 0, right? Because f of x equals 0 when you're intersecting the x-axis. So you would say x squared plus x minus 6 is equal to 0. And just factor this quadratic. X plus 3 times x minus 2 equals 0. And you would learn that the roots of this quadratic equation, of this quadratic function, are x is equal to minus 3 and x is equal to 2. Now how would we visualize this? Well, let's draw this quadratic function. Those are my very uneven lines. So the roots are x is equal to negative 3, so this is right here, x is at minus 3, y is 0. By definition, one of the roots is where f of x is equal to 0, so the y, or the f of x axis here is 0. The coordinate is 0, and this point here is 2, 0. Once again, this is the x-axis, and this is the f of x-axis. And we also know that the y-intercept is minus 6. This isn't the vertex, it's the y-intercept, and then the graph is going to look something like this. And not as bumpy as what I'm drawing, which I think you get the general idea if you've ever seen a clean parabola. It looks like that, with x minus 3 here and x is 2 here. Pretty straightforward. We figured out the roots, we figured out what it looks like. Now, what if we, instead of wanting to know where f of x is equal to 0, which is these 2 points, what if we wanted to know where f of x is greater than 0? What x values make f of x greater than 0? Or another way of saying it, what x values make this statement true? X squared plus x minus 6 is greater than 0, right? This is just f of x. Well, if we look at the graph, when is f of x greater than 0? Well, this is the f of x axis. And when are we in positive territory? Well, f of x is greater than 0 here. Let me draw that in another color. Is greater than 0 here, right? Because it's above the x-axis. And f of x is greater than 0 here. So just visually looking at it, what x values make this true? Well, this is true whenever x is less than minus 3, right? Or whenever x is greater than 2, right? Because when x is greater than 2, f of x is greater than 0. And when x is less than negative 3, f of x is greater than 0. So we would say the solution to this quadratic inequality, and we pretty much solve this visually, is x is less than minus 3 or x is greater than 2. And you could test it out. You could try out the number minus 4 and you should get f of x being greater than 0. You could try it out here. Or you could try out the number 3 and make sure that this works. And you can just make sure that you could, for example, try out the number 0 and make sure that 0 doesn't work, right? Because 0 is between the two roots. It actually turns out that when x is equal to 0, f of x is minus 6, which is definitely less than 0. So I think this will give you a visual intuition of what this quadratic inequality means. And now with that visual intuition in the back of your mind, let's do some more problems, and maybe we won't have to go through the exercise of drawing it, but maybe I will draw it just to make sure that the point hits home. Let me give you a slightly trickier problem. Let's say I had minus x squared, minus x squared minus 3x plus 28, let me say, is greater than 0. Well, I want to get rid of this negative sign in front of the x squared. I just don't like it there because it makes it a little more confusing to factor. So I'm going to multiply everything by negative 1, both sides. So I get x squared plus 3x minus 28. When you multiply or divide by a negative with any inequality, you have to swap the sign. So this is now going to be less than 0, right? And if we were to factor this, we get x plus 7 times x minus 4 is less than 0. So if this was equal to 0, we would know that the two roots of this function, let's define the function f of x. Let's define the function as f of x is equal to, well, we can define it as this or this because they're the same thing. But let's just for simplicity, let's define it as x plus 7 times x minus 4. That's f of x, right? Well, after factoring it, we know that the roots of this, the roots are x is equal to minus 7. Excuse me, my throat is dry, I just ate too many almonds. And x is equal to 4. Now what we want to know is what x values make this inequality true. If this was inequality, we'd be done. We want to know what makes this inequality true. And I'll give you a little bit of a trick. It's always going to be the numbers in between the two roots or outside of the two roots. So what I do whenever I'm doing this quick on a test or something, I just test numbers that are either between the roots or outside of the two roots. So let's pick a number that's between x equals minus 7 and x equals 4. Well, let's try x equals 0. Well, f of 0 is equal to, we could do it right here, f of 0 is 0 plus 7, times 0 minus 4. This is 7 times minus 4, which is minus 28. So f of 0 is minus 28. Now, is this is the function we're working with. Is this less than 0? Well, yeah, it is. So it actually turns out that a number, an x value between the two roots works. So actually I immediately know that the answer here is all of the x's that are between the two roots. So we could say that the solution to this is minus 7 is less than x, which is less than 4. You could have done it the other way. You could have tried a number that's outside of the roots, either less than minus 7 or greater than 4, and have tried it out. Let's say if you had tried out 5, try x equals 5. Well then f of 5 would be 12 times 1, right, which is equals to 12. F of 5 is 12. Is that less than 0? No. So that wouldn't have worked. So once again, that gives us confidence that we got the right interval. And if we wanted to think about this visually, right, because we got this answer. When you do it visually, it actually makes, I think, a lot of sense, but maybe I'm biased. Let me erase this real fast. If you look at it visually, it looks like this. Oh, whoop, that's way too fat. Let me draw it on a skinnier pen. If you draw it visually, and this is the parabola, right? This is f of x. The roots here are minus 7, 0, and 4, 0. We're saying that for all x values between these two numbers, f of x is less than 0. And that makes sense, because when is f of x less than 0? Well, this is the graph of f of x, right? This is f of x. And when is f of x less than 0? Right here. So what x values give us that? Well, the x values that give us that are right here. I hope I'm not confusing you too much with these visual graphs. And you're probably saying, well, Sal, how do I know I don't include zeros? Well, you could try it out, but well, how come I don't include the roots? Well, at the roots, f of x is equal to 0. So if this was less than or equal to 0, then the answer would be negative 7 is less than or equal to x, is less than or equal to 4. I hope that gives you a sense. You pretty much just have to try a number in between the roots and try a number outside of the roots, and that tells you what interval will make the inequality true. I'll see you in the next presentation.
Alright, so based on what you saw from that example, why don't you give one a try? We've got the inequality x squared minus 3x minus 10 is less than or equal to 0. Try to use the algebraic method that Salman Khan showed you to come up with the x's that would be solutions to this inequality. When you think you've got it, come back and check your answer. Alright, so if we go through his process, we first need to take a look at our function of x squared minus 3x minus 10 and figure out the roots when that is equal to 0. So that would factor to x minus 5 times x plus 2, which would make the roots positive 5 and negative 2. So if I pick an x value between those two, like 0, I can test the 0 by putting it back into either the original ax squared plus bx plus c form, or you can also use the factored form, whichever you feel is easier. But we end up with a statement like negative 10 is less than or equal to 0, which is a true statement. So since my test value gave me a true statement, and my test value was a value between my two numbers, then I know it's all of the x's between the two roots that are going to be my solutions. And notice here, because we started with an inequality that was less than or equal to, we include less than or equal to in our solution. Alright, so that should be the information that you need in order to complete the practice problems for 1.8 in your book. Make sure that you are getting your questions answered as they arise, and make sure you are checking your practice with the answers on Canvas to make sure you're on the right track. And this is our last lesson for this chapter, so in the next few days you'll be preparing for one more quiz and then be preparing to retake the quadratic chapter test. I hope you do really well on it. Let me know if you have any questions. And we'll see you when we start chapter 3. I'm sorry, chapter 2. I'll get it right yet.